Hi guys. So finally the videos for the piecewise function homework 2.2.5, and this is just to kind of review. Out of everything that we've learned, I think piecewise functions are pretty straightforward, and some of you guys are having an issue because you are overthinking it. So piecewise function is just like it sounds. It's made up of pieces. And how are the pieces separated by? Well, they're separated by the domains. Okay, and the domains in the parameters of the domain dictate which function, which actual function equation we use. So if I look at the first problem, we have find f of -9. So that's the x value. The -9 is the input. So -9 is going to be less than or equal to 0. So I'm just going to use 1. So that's just going to equal 1. And then I have f to the 0. 0 is going to fit into this parameter right here of where x equals 0. So that is going to, the output of that is also going to be 1. F to the pi is going to be, pi is 3.14, I don't know, something, but it's going to be greater than 0. So that's going to be, I'm going to use this function right here. That is going to be -1, f to the 99. That is also greater than 0. So we're going to use the output of -1. It says sketch the function. So we can use those points, or those are just horizontal lines. So let's go ahead and draw. Okay, and then we have 1 and -1. So I'm going to draw the entire -1, and it's from where x is greater than 0. So let's open up that circle. And it's going to be greater than 0. And then those points where x is less than or equal to 0, right here. Okay. And that's going to be that right there. Okay. And then let's go ahead and state the domain and range. The domain is going to be all real numbers. And range, we can write it in a simple set because we can't really write all real numbers. So let's just go ahead and include it in a simple set, -1 and 1. Okay, good job, guys. Number 2, let's go ahead. Oh, first we need to do A. Okay, so we have f of -4 and -4 right here is less than or equal to 0. So we're going to use that function, -4 squared. So the output of that is going to be 16. F of 0. Once again, we're going to use this because x is less than or equal to 0. So we put 0 squared in, which gives us 0. F of 1, we're going to have to use this one here. And that's going to be 4 minus x squared. Oops. Let's go ahead and substitute that 1 in. So that's 4 minus 1, which is 3. Okay, and we can use those points to sketch the graph, but they're just functions. We're not having any dilations on these. So I'm going to draw the x squared, and that's just the parent function. And it starts at x is less than or equal to 0, so it's going to include the 0, and it's going to go here, and there is my parabola, right, like that. And then this, if I rewrite it, it's going to be negative x squared plus 4. So it reflected over the x-axis and then went up 4. 1, 2, 3, 4. Went up 4. And then down 1 to the left 1. Okay, and these are all the points that are greater than 0. So we're going to put an open circle here. And it's going to look something like that. Okay? Now, let's go ahead and identify the domain. Domain is going to be all real numbers. And the range is going to be also all real numbers. Okay? Good job. Next one. Okay, so number 3. Let's go ahead and find these values. A, f of negative 1. We're going to use the linear function. Negative 3 minus 1, which is negative 4. F of 0, we're going to use the linear function again. Negative 1. F of 8, I'm going to use the radical. So 8 plus 1 equals 3. And then let's go ahead and graph it. Okay, let's put some points on. Let's go ahead and do this. Let's graph the linear function first. Start at negative 1, 1, 2, 3, 1. But we're going to the negative side. We're going to less than 0. So 1, 2, 3, left 1. There it is. I don't need that little dot there. And then let's go ahead and draw the radical. Okay, so we have the radical, so y equals x plus 1, so we know it moved left 1, so it's going to be left 1 and up 1 and to the right 1. That's where our circle is going to be, that open circle. Okay, and I'm going to put in a point that is going to make this a perfect square. That's easier to graph integers. And y equals 2. So that's going to be 3, 2, 2, 3, 1, 2. Starting from here, it's going to look like that. I'm just going to eliminate that little dot right there. Nope, didn't work. Try this small eraser. There we go. Okay. Let's go ahead and identify the domain and range. The domain looks like it's going to be all real numbers. Okay. And then the range, we have a little space here missing. Right here, that little space right there. And so it's going to be x such that x is an element of all real numbers. Y has to be less than or equal to negative 1, or y has to be greater than 1. It has to be greater than 1. It has to be less than or equal to negative 1. Okay? Good job. Next problem. A, find f of -1. -1 is going to be the absolute value function. -1 plus 1 equals 0. Okay. Next one, f of 0 is going to be the one that's less than, no, it's going to be greater than -1, so it's going to be the radical. 0 plus 1 equals the square root of 1 equals 1. F of -4 is going to be that's the absolute value. And so that's -4 plus 1 equals the absolute value of -3, which is 3. And f of 8, which is we're going to use the radical. 8 plus 1 square root of 9 equals 3. Okay? Let's go ahead and draw those two piecewise functions, or just one piecewise function. And then one, just like that. Okay. So let's go ahead and draw the absolute value function first. We know it moved left 1, open circle, and it's not going to go to the right side at all. So we're just going to focus on that negative slope. So up 1 to the left 1, up 1 to the left 1, something like this. Okay, and then let's go ahead and draw. And then let's go ahead and draw the radical. Okay, also it moved left 1. So it's going to start at the same point. Okay, and so up 1 to the right 1. And then let's go ahead and put an input in there that would make it a perfect square. 3 is the perfect input. Okay, so that's 3, 2. So 1, 2, 3, 3, 2, just like that. Okay. And then let's go ahead and find the domain and range. The domain for this function. Well, I forgot to fill in this because that little -1, because the radical function included that point. And you just fill it in. So the range of this, the domain of this is going to be all real numbers. Okay, the range looks like it's all greater than or equal to 0. So y is such that y is an element of all real numbers, y is greater or equal to 0. Okay? Good job. Number 5. So they want us to write the piecewise function for this. So f of x equals, we can draw our bracket. We're going to look at this line right here first. It looks like a linear function. Okay. And the way you do that is you find slope. I'm going to pick that point right there. That looks like a good point right there. And that looks like a solid point right there. So we're going to go from this point, we're going to go up 3 and to the right 1. And that's a positive slope. So up 3 and right 1, that's 3x. And then we have to figure out the y-intercept. Okay. So how do we figure out the y-intercept? You can continue to go up 3, 1, 2, 3, and to the right 1. And then, or you can just go ahead, since we have 3x plus b equals y, you could just input one of the points. You could input this point right here, -2, 4, as your x and y. So 4 equals 3 times -2 plus b. 4 equals -6 plus b. So b is going to be 10. So we get a 3x plus 10. Now we have to define our parameters. So I can include this point right here, and I can say x is less than or equal to -2. Okay. Now it looks like from here to here it's a horizontal line. And so what is that horizontal line? It's just going to be 4. It's going to be 4. And then we define the parameters of that part of the piecewise function. So x is going to be greater than -2. It can't be equal to, because we've already used up this point on that linear function. Okay? And then greater than 2. Or you can put equal to 2. Okay? Now let's go ahead and find this piece. Well, pink on pink is not working, is it? Okay. Let's try to find that one. Okay, so let's take 2 good points. We have a point here, and looks like a point here. Down 1, 2, 3, down 3, and to the right 1. Okay. And then, so that is going to be -3x. Do you see symmetry? Do you see symmetry between those two lines? Yeah, in fact, I could have made that an absolute value function. So I have a feeling that the y-intercept is going to be +10. Okay, because it looks like to me that this line right here and that line right there is symmetrical. Okay, so that if I extend this, okay, I can actually write an absolute value function for that. Okay, but we didn't start that way. We wrote 2 linear functions, so that's fine. Okay, and that is going to be kind of interesting because we would have 2 x parameters for that. Okay, so since we used up this point on this horizontal line right here, we have that equal to right there. So now x is going to be greater than 2. Okay? Good job. Number 6. Rewrite as a piecewise defined function. Okay? Let's go ahead and split up these two. Next, f of x equals 2x plus 4, and f of x equals -2x plus 4. Now, how did this function move? We have to find that point. Okay, so to figure out how the left and right movement is, because if we have a function here, and if we wanted to write that as a piecewise function, we would have to find the x value, okay, of that vertex. We would have to find the x value of that vertex. So we take out the 2, factor out a 2, negative, and it's going to be the same for both. They move the same way. Okay, and then we know it moved left 2, so this x is now a -2. It's a -2, 0, in fact, because it didn't move up or down at all. So when we split these two up, now it's going to turn into f of x equals 2x plus 4. And 2x plus 4 is going to be that positive slope side. So when x is greater than or equal to -2. And then that absolute value, negative 2x plus 4. And that's when x is less than -2. Okay? Good job. Let's go look at B. Let's go ahead and split those up. F of x equals, so we have a 3x minus 9, negative 3x minus 9. Take that first function right there. Okay, take out the x. So now we know it moved right 3. So that point is going to be 3, 0. So that's where it gets split up. That line of symmetry is going to be x equals 3. So we can put x is greater than or equals 3. X is less than 3. Okay? Now there was no instructions, but you can clearly see that I wanted you to write a piecewise function equation for this. So I'm going to first do this linear function right there. So that's going to be f of x equals your bracket. Let's go ahead, and there's 2 good points right there. Down 2 and to the left, or up 2 and to the right one. That's positive slope. So that's going to be 2x. Okay. And then we're going to say 2x plus b. We could use this point right here. We have 0 equals 2. And then 2, negative 2 plus b. So b equals 4 plus 4. Let's go ahead. That's not 4. That's b. Let's go ahead and identify the parameter. Okay. Now, so we have, that is going to be x is less than or equal to -2. Next, let's go ahead and tackle this horizontal line. So that is going to be a 1, and it's going to be between -2, and it's just going to be, x is going to be greater than, not equal to, and then less than or equal to 1, because we have the solid dot right there. Okay, now let's tackle this line right there. So I don't like that half. I'm going to use that point right there and this point right there. Down 1, down 1, and to the right 2. Right 2, that's -1/2. And if I write that, -1/2 x plus b. I'm going to put in this point right there, 2, -1. So we have -1 equals -1 plus b. So b equals 0. It doesn't, y-intercept is at 0. And x is greater than 1. Okay? Good job. Next. We have this very interesting graph. We just have a linear function and a dot. Okay. So the way I would represent that, f of x equals, let's go ahead and represent that linear function. I see a good point there. I really don't. Oh, I see one right here. Okay. Up 1, 2, 3, 4. To the right 1, 2, 4, 5. 4/5 x. Find the y-intercept for that. Y equals 4/5 x plus b. We're going to use that point, -1, -1. -1 equals 4/5 times -1 plus b. -1 equals -4/5 plus b. So -1 plus 4/5 equals b. So b equals -1/5. So -1/5. Okay. And how do we represent that? Well, it equals everything, all real numbers, except one x. It cannot be -1. How do I represent that dot? I could imagine that there is a horizontal line here. Okay, so that line would be 2. And that is only when x equals -1. There you go. Is there any more? Well, I could have done more of these. These are fun. And good job.